Okay, so let's do some different kinds of u substitutions. So let's start with just an easy one. So let's remind ourselves of how to change limits of integration as well. So let's do here, easy u equal 4 plus 3x. So du is 3 dx. So I see that 1/3 du is dx. All right, so I see that's dx right there. It gets replaced with 1/3 du. And I have the integral the square root of u. So let's go change our limits of integration. So remember, what we do is we put x equals 0 into u equal 4 plus 3x. So that gives us u equal 4. And then I put x equals 7 into u equal 4 plus 3x. So that gives us u equals 25. So my new limits of integration are 4 to 25. So I'm not going to go back to putting the x's back in. I'm going to rewrite this as u to the 1/2. And then I'm going to integrate. So carry the 1/3 along. You're going to add 1 to the exponent. Multiply by 2 over 3. And then I'm going to substitute in 4 and 25. So I get 2/9 times 25 to the 3/2 minus 4 to the 3/2. And since I can take the square root, I'm going to go do it. So the square root of 25 is 5 cubed is 125. And then I'm going to be subtracting off the square root of 4, which is 2 cubed, which is 8. So 2/9 times 117. All right, so let's look at this one here. So you can see, and let's just start with the process. If I let u equal 9 plus x, the inside of the radical, I get du is dx. So let's just rewrite this so we can see what I've got here. So 9 plus x, and then I have this x dx that I need to take care of. So this is square root of u. Used to that. So I need to have x and dx. So dx is exactly just du. So how am I going to get x changed into u's? So that's where I come back into this, which changes everything from x's to u's. So I want you to see that I could take this line and I could make it u minus 9 is x. So instead of x here, I'll put in u minus 9. I'm going to go change the limits of integration again. So if I put x equals 0 into my conversion, I see that I get u equals 9. And if I put x equals 7 into my conversion, I get u equals 16. So 9 to 16. All right, so I see 9 to 16. I'm going to have to multiply this out in order to take the antiderivative of it. So I'll get u to the 3/2 minus 9u to the 1/2. Making sure you add exponents. All right, so the next step will be to take the antiderivative. So I'll get u to the 5/2 over 5/2 or times 2/5 minus 9. And that'll give me u to the 3/2 or times 2/3. And then 9 to 16. So 2/5, 16 to the 5/2 minus 18 over 3. I guess I should change that to 6. 9 to the 3/2. And I'm just going to stop there because I'm running out of room. All right, so let's look at this one. So this one here, let's look at perhaps letting u equal the denominator. Sometimes that's a good inside function. So du gives me e to the x dx. So let's separate this out in the numerator here to see what I've got. So I've got e to the 2x times 1 over 2 plus e to the x times dx. All right, so this can change into 1 over u. This e to the 2x, what can I do with that? I need one of the e to the x's to be taken out to put the du in. So let's rewrite that even further. So 1 over 2 plus e to the x, e to the x, e to the x, dx. So this can be taken out to get my du in. This, I can use my u substitution. So it's this right here that I have to worry about. How am I going to get a u in here for this? Because everything has to be in u's. All x's to all u's. So I'm looking at this e to the x, and I'm looking at this statement right here, and I think e to the x can be written as u minus 2. So u minus 2. All right, so now let's do some little bit of algebra here. So this is like saying u minus 2 over u du. I can separate a fraction around the subtraction in the numerator. So let's do that. So u over u minus 2 over u du. So that gives me 1 minus 2 over u. So that's u minus 2 times ln of u. And then I'm going to go put the x's back in. So I get 2 plus e to the x minus 2 times ln 2 plus e to the x plus c.